Today we're going to learn about complex rational expressions. Again, rational expressions are expressions that look like fractions. Complex just means that they're more difficult, obviously, but it usually means something like this, where there's fractions within a larger fraction, and you'll see some more examples as the next couple days go on. First thing I want to talk about is what I call implied parentheses. If you think back to elementary school, when you had a problem like this, if we followed order of operations strictly, you would think, oh, I'm supposed to divide before I add. But we all know that we do the 3 plus 7 first. That's because the top and the bottom of a fraction, the numerator and denominator, kind of have, again, what I call implied parentheses, meaning that this is in parentheses. So then when we do the order of operations, that comes first because parentheses come first. So when you look at a problem like this is a division bar, but this numerator and this denominator are both in implied parentheses. So you're going to do both the top and the bottom first before you go to divide. So how are we going to attack this thing? Well, this numerator is just an addition problem. So we have to remember how to add rational expressions. Well, in order to add, we have to have common denominators. So right now, the denominator of that one is 1. So we would need to multiply this by y over y. Could we multiply that one by 1 over 1? Sure, but there's already a 1 in front of that y. So we would end up with y over y plus x over y. These on the numerator are not like terms, so we just end up making that y plus x over y. Then we do the same thing in the denominator. So again, right now that's over 1. Make our common denominator, so we multiply this guy by x and this guy by x. So we get x over x plus y over x. Combine my like terms in the numerator, so I get x plus y over x. Put my division bar back in. So again, a fraction is just division. That's all it is. So basically we just have this divided by this. So let's write it the way that we're used to seeing it. Y plus x over y divided by x plus y over x. Then to divide rational expressions, I take the reciprocal of the second one. So that would give me y plus x over y times x over x plus y. And remember, in multiplication, we don't actually multiply, we factor and cancel. So here I want to see if there's anything I can cancel. And remember, addition can be done in either order. So these two things are exactly the same. So those can cancel to just a 1 or just cancel out, however you want to think of that. So all we're left with is x over y. And that's our answer. All right, let's try a little bit more tricky one. Same concept, but we just have to have an uglier looking problem. So again, here's my big division bar. So there's an implied parenthesis here and implied parenthesis here. So I need to do the numerator, do the denominator, and then I'll divide. So start with my numerator. I need to make common denominators. My common denominator here would be a and b. So in this case, this one needs the a, so I multiply by a. This one needs the b, so I multiply by b. Be very careful here. People their brains get ahead of them. They know that this is supposed to be ab, but when they see the a up here, they want to multiply it by b and gets all messed up. So just take your time and make sure that you're multiplying the exact same thing in the numerator and denominator. All right, so when I do that, I get a squared and over here b squared. Again, then I actually need to subtract. So those aren't like terms, so I can't put them together, so I just write them side by side over a plus b. Now, I'm going to do the same thing in the denominator. Right now, this 2 is over 1. So if I want to make my common denominator is going to be a and b and 1, but the 1 we don't really need. So we're going to make those all AB. So that means this one needs, let's see, I just about made the silly mistake I told you not to. That one needs an A, so there we go. This one needs an A and a B. This one just needs the B. So we have a squared. Here in the middle we have 2ab. Here in the back we have b squared. So when we combine those together, we get a squared plus 2ab plus b squared over ab. And again, we put our big division bar back in. So now we just need to do our division problem. Again, set it up like you're used to seeing it. A squared minus b squared over ab divided by a squared plus 2ab plus b squared over ab. To divide, we take the reciprocal and multiply, and we're going to go ahead and factor why we're doing that, because again, we have to factor and cancel. So this top left is the difference of squares, so that factors into a plus b, a minus b. Bottom left, that's a monomial, so we don't factor that, that's just ab. Now I'm going to take the reciprocal, so this ab is going to go to the top. And then here, remember, we factor this like a normal trinomial. There's a 1 there. So we're looking for two numbers that multiply to give us 1, add to give us 2. So that's a plus 1 and a plus 1. But then behind the 1s, we have to put in the b's to make the b squared. So this is what it looks like when it's all factored. My ab's cancel. My a plus b's cancel. A minus b and a plus b are not related in any way, shape, or form. So those cannot cancel. So our answer is a minus b over a plus b. Now if you notice on these problems I did not do restrictions. We're not going to require you to do that in this section just because it just gets a little bit messy. Alright, couple problems for you to try, and I gave you the answers there at the bottom. But again, just writing down the problem and the answer, that doesn't count as you trying. You actually have to try. Have a good night.